Northwest Climate Impacts Research Consortium. We're a NOAA RISA team. So this is the third webinar in our series on evaluating decision support tools and resources. Today, Holly Hartmann will talk about decision support tool sustainability. So what happens with your tool after the project funding ends. So Holly is the Director of Climate Science Applications for Carpe Diem West. She is a leader in research related to the development of decision support tools for climate, water, and other resource management applications. Holly joined CERC in 2015 to help us develop and improve our decision support tools and resources. So like Kai mentioned, this webinar series is targeted toward our CERC team members, but we have invited and welcome a wider network of people who also work in this space. So after Holly's presentation, we'll have about 15 minutes of time for questions and discussion. And so CERC team members, feel free to unmute yourself if you'd like to ask a question, and like I mentioned, others, please raise your hand and we'll be happy to hear your question or comments. Okay, so Holly, you can take it from here.
Great, thanks Megan. First off, I want to just start off by saying thanks for coming to this webinar. This will be, I think, the most difficult webinar to get through in terms of evaluating decision support tools. And that's just because there is a lot of maybe jargon and technical terminology that we don't encounter in a lot of the other ways of looking at and evaluating decision support tools and resources. So I appreciate you being here, and I am very much open to any suggestions about better ways to communicate this topic, because it's not easy to deal with some of the technical jargon. Right? So the outline of this presentation is going to follow similar to what we've done in the first two webinars. I just want to briefly introduce how I'm framing decision support, talk a little bit about my start in this topic with regard to the transfer of or the sustainability of decision support tools, connect this to the overall decision support tool assessment framework within CERC 2.0, and then we'll get into the meat of this sustainability topic. So just to reiterate, you've seen this before, but in case anybody here is new, sort of the definition we're using for decision support is more than just producing and disseminating information and data, but it's about facilitating the use of that data and information in order to improve decisions. The implication for us in thinking about the sustainability of decision support tools is that if we're really helping to connect data and information with the wisdom of decision makers and develop through knowledge development, the implication is that we need to have customization of information, customization of engagement, and then a commitment to continuity of that engagement, because it takes time for decision makers both to learn tools and to learn how to integrate that information in their decision process, especially if it's an agency or an organization using formal decision processes. So we are talking about how do you sustain a tool over the long term to support those decision makers over the long term. Another perspective, another way of looking at this is from the climate science enterprise, the overall enterprise perspective about the development of decision support tools. If you think about it, we've got decision makers all over the country making all kinds of decisions related to climate at different time scales, different space scales, and the research funding for development of those tools happens on a much different scale. It is, we have pilot projects or just experimental projects, and there is no way that we can afford, that the agencies, the whole enterprise can afford to come up with research projects for every decision for every part of the country in terms of unique tools that serve just those decision makers. So from the overall climate science enterprise, the concerns are about the transferability of information and tools, the scalability of those tools, and then their sustainability in ways that can create change in decision-making processes across the country, not just for the group of decision makers that we work with. So it's a pretty immense challenge. Just by way of sort of how I got started in this area, the very first technology transfer experience I was involved with was in the 1980s, transferring software for hydrologic modeling within an agency, within NOAA, that it was all planned. We were all set. We had done all the right things to work with the team in the other institution. We got on site, the two of us, and we were assured of what compiler and what machines we had available to us, so that we were working with Fortran 77 for those of you who've been around. We got there and they only had a subset of Fortran 66. So we had to completely recode everything, working from 9 in the morning till midnight, 7 days in a row to get that code workable. We had one shot to get it right. The challenge hasn't changed over all that time. So it's the details of everybody's technology transfer challenge may be different, but those challenges I've encountered in different forms ever since. And I don't think there's a software development team, and certainly CERC 2.0, every one of the teams is in the kind of the same boat. Is it thinking about how do you sustain the tool and what kind of challenges will you have in transferring it? So here's how these are the 3 CERC 2.0 R&D questions related to decision support tools. What we're going to talk about here today relates particularly to question 1 about how can the tools facilitate adaptive capacity, which gets at that continuity of commitment to those tools to support decision makers in their decision-making process. And then in question number 3 about how should the tools and their use be evaluated. Is it enough just to develop the tool, or do we also get evaluated on how we transfer and sustain the tool, through any of several different processes. So this is the 3rd webinar, just to lay out kind of how this fits within these 4 different frameworks that I have in the white paper that I think all of you have seen, or at least seen parts of. Megan can make that white paper available to anybody who wants it. We've got the webinars recorded for the first 2. I'll talk about future webinars at the end. But you can kind of see that we're focused here on the framework B in that white paper, on the perspective of the whole climate applications enterprise, which is about the sustainability of the tools and decision resources that we develop. Just to show you how this connects with our last webinar and talking with the design priorities, you may remember this slide that just talks about what your priorities for development are, and then the implication being that if you are focused on equity of access, then we need tools that can be used by a wide range of users that want customized analysis, and that will require eventual scaling up of the use of the tools and maybe facilitation of intermediaries. And so how do you sustain tools that can do those things? How do you provide for upscaling the tool and broadening the range of applications and making those tools available over time? So you can see that this, what we'll talk about today, comes out of this design priority of focused on equity of access that ultimately then says that we're trying to develop customizable tools that will be around for the long term. This notion of having trouble in sustaining tools or transferring tools has been around for a long time. This is just a slide that represents how this challenge often gets represented. It's sometimes called the valley of death, of just the connection between bridging that gap between research and operations, and how there's often just a mismatch between what the 2 kinds of groups are trying to do. And that word operations can be troublesome for, it's kind of a jargon word. What this means is that for some agencies that have day-to-day responsibilities to support decisions either within their agency or the public or by the public, they need tools that are available kind of 24/7 reliably that can be accessed and used, so that the code isn't down or the service isn't down sometime. An example would be our weather forecast, but there are many other examples as well. So there's been, you can see out here on the around the border, there's been many reports over the decades, and this is just a small sampling of National Academy of Sciences reports that come out and say this gap, this bridging of research and operations, or research and the support of operational decision making, is just a mess. It's a real challenge. And it's not just in our discipline. It happens in, there are equivalent reports and equivalent challenges in pretty much every sector that the National Academies address. And every federal agency has a technology transfer group or unit that is faced with the challenges of trying to get their funded research, even internal and externally funded research, integrated into operations. This is maybe a little more sophisticated look at that challenge. It's from a business perspective, where you can see the expenditures in the gray line, that is net expenditures being just a cost as the development goes on, research and development of technology, in this case decision support tools. For academic research or agency research, the challenge is that that curve never goes up, which would be the marketing and the commercialization of a tool. Everything that goes on with a tool is considered a cost. And once it goes past research and development, there's often pressure to say, well, what are we getting out of this extra expenditure? It's not research anymore. It's not development anymore. And so the challenge is, who wants to take on that cost? And that can be a real challenge. So in going the next step then, and looking at this notion of sustainability, in the white paper, I have this, the title of this framework is Technology Sustainability, and there were 3 steps: sustainability, transferability, interoperability. This is part of just the communication issue. That's just a lot of abilities. So if there's any suggestions on how to kind of fix this or improve the communication of this, I'd appreciate it. I have changed that first one of sustainability to more, I think maybe a little more effectively communicating what it's about, is about the challenges of commitment and continuity of the resources, of the decision support resources. The second one is more about the transfer of the software or databases. And then the third one is much more technical, I think, than the other 2, that has to do with how software integrates with other software. Conceptually, you could talk about how any kind of decision resources connects with the decision process and other tools, but we've got other frameworks that maybe address that a little better. So the point I want to make here is that there are 3 kinds of issues. There are technology issues, and I'm going to focus mostly on the back end, the part that people never see. It's not the front end issues that we dealt with in our first webinar. This is more the back end, where yeah, people don't see what goes on, and the easier a decision support tool looks, and it is the easier it is to use on the front end, actually the more work that's been put in on the back end. But it's not just technology issues, it's also people and institutional issues. We often rely on one, or only have access to 1 or 2 people within a software development team or a decision support development team. And we rely on that one technical person or 2 technical folks to know multiple technologies, whether it's GIS, whether it's web services, whether it's databases, whether it's that web interface development, or whether it's security, optimization. We rely on them for a lot, and I think this is my place to make a pitch to recognize that technical, IT folks aren't experts in all areas of IT, and that it's helpful to try to get specialists for specific topics. And then there's also people issues, and that has to do with more processes when people are trying to collaborate or do the transfer, and I'll get to those in a bit. I do want to throw in another, just a quick story about how this challenge of making use of people that have a lot of technology training and how they can be asked to do so many things. When I was director of the Airlands Information Center, we were asked to help an agency, an office, I won't say what agency or office it was, to figure out how to install or make their browsers be able to use Java so they could use a particular tool. We met with them. It turned out within their whole office, they had never installed the service pack updates for their PCs, for their Windows machines, ever since they got them. So that our IT people spent days helping them get all of their machines up to date and the security situation taken care of before we could even address their first question, which is how can we use your tool through a browser. So that's we often ask a lot of the IT folks that are working on decision support tool development, and it's I'll make a pitch to try to protect them from doing all tasks. It can really slow down and interrupt a project. So let's get into the meat of these three areas of commitment and continuity, then transferability and interoperability. So within this area of commitment and continuity, the idea is that, if a decision support tool is expected to really serve decision makers, it needs to be reliably maintained beyond the lifetime of the project that funded its development. And the long-term maintenance of code is typically more expensive than the initial development, especially as time goes by. And then as the decision makers interact with the tools, and I'm sure many of you have already experienced this, the decision makers want more functionality, so that what your tool originally did, it now needs to do more. But to support that ongoing maintenance and expansion of a tool, there's got to be the numbers of users to support that. So the question is how do you get enough users? And so it may be that you need to go into different markets, that is different sectors, or into different regions to get enough of a user base to justify ongoing maintenance costs. And I think the Climate Ag Toolbox is a great example of this, about connecting sets of tools, connecting projects to create then enough of a user base, and that's requiring new functionalities, expansion to different regions, connections with different data sets, and scaling up then for the number of users. This scalability issue focuses on how many simultaneous users a decision support tool can support. Often in kind of the research and development phase of a tool, this isn't an issue. But when it comes to actual operations, when you have scaled up to support more regions, more users, more sectors, it does become an issue. Can you handle 1,000 users or even dozens of users working simultaneously? And you may think that your tool may not have to accommodate that, but just at its most simple, think about training exercises for different users when you may have 50 or 100 people, whether you're in one place physically or remotely, doing training about how to use your tool. Then you will have many people using that tool simultaneously. So you'll need to make sure that kind of all the threads of the interactions get handled correctly, and that there may be load balancing issues for your for your machines as you scale up to larger number of users. And then there are also issues of maintainability. Again, maintenance is probably one of its can be the biggest cost in the development of software tools over time. There's ways that the whole maintainability of tools is encompasses both process issues and who's participating in that maintenance. Some things to be concerned about are staff turnover, and it's one that I've seen over and over again in projects. Is it whether it's at the research group level or at the agency level, is staff turnover can just bring something to a halt. And then the folks that may be available to manage the tools over the long term may be more junior programmers, or maybe even people that aren't really formal programmers, but have become IT people by virtue of being the projects they've worked on within their area. For example, that's how I got started. My training's in hydrology, but I ended up doing software development as a way to focus on, because of the projects I was involved with. So is there sufficient documentation that allows for staff turnover and that will allow junior programmers or non-programmers to actually do the maintenance of the code? The next issue deals with refactoring, and that means having to actually recode your software as hardware changes and as software changes. Now, it used to be that we had tools that were dedicated, we had dedicated servers, and every time the server hardware changed, we'd have to redo things. Now at least we have virtual machines so that you can keep a system more stable, and that as tools change, you can have multiple tools, each with their own virtual server. It's a lot easier to manage, but there still inevitably will be a need to just recode big chunks of your tools. And so thinking about the plan for that over the long run is important. And certainly browsers change all the time. So even just on the user interface, there are challenges. So the other maintenance issues are security issues. That is, how can you deal with security problems that inevitably come up? I've had experience with a tool that was simply destroyed. It was one that we were asked to come in and fix, is that the whole project came to a halt when the database behind that tool was hacked and there were porn images all through the database. It just brought the whole project to a halt. So that project simply didn't have any money at all to deal with how to deal with that. And then the last deals with, if you are able to keep your tools running and you're increasing the scale of users, then you will have to think about how to optimize the balance, optimize the code that will slow things down, or how do you balance the load on the servers that are supporting the tool. Now, so that's the first one on commitment and continuity. The next has to do with transferring code. There's a couple of elements of this, but at the first most basic level are your options for transfer. And you can see in the red box that we often talk about, transfer of tools as a goal, is sort of, and I say that with goals with the exclamation point, and I put little quotes around it, even I think air quotes, because people may talk about what their goals are, but what we really want for our tools may be quite different than what we say sometimes. We have sort of their equivalent of sort of life goals versus practical goals, I guess, is a way to look at it. There's reality when it comes to this transferability. One option, and I think it's often a common option within academia, is that there's no transfer at all, that a research group continues to take care of its decision support tools for years and years. There's nothing wrong with that. It can be a great base for doing a whole research career. The challenge from the climate science or the climate applications enterprise is that how do you support that over the decades for so many parts of the country, so many researchers, so many decision contexts. It also can present a challenge of sort of the tail wagging the dog, whereas all your projects have to work to, so many other projects have to work to sustain this tool, that it really sort of limits what you're able to do in other research projects, because you've got to focus on keeping this decision support tool going. Another option is to do a business spin-off. This often is accompanied with that decision or design priority not being equitable access, but focused on a high return on investment. Personally, I've experienced the pressure to do business spin-offs with code, not from potential users, but from the university who sees that there could be value, or they've heard that there's value in decision support tools. I think most of us know that the reality is a little different in who would pay for what, but there are examples of success with this, whether it's lightning detection tools, or riverware is an example in hydrology of a tool that was developed within the university that now is a private sector enterprise. It's another approach is sort of this turnkey transfer, where you just send your code out. Some of the challenges associated with that are that now you as a researcher are not connected with your code. So do you have to keep a second version, and now you've got duplicate versions? How do you handle updates? How do you handle ongoing research changes? Another difficulty is this issue with agency mandates to try to get the scale correctly in terms of serving sectors and regions. If you're working originally with a state agency, that may not provide enough users to support long-term sustainability of that tool. So, or the sectors, if you cross sectors, even at that federal level, you may end up with limitations posed by the mandate of that agency. So turnkey transfer can be it's often seen as like an easy way out, but it isn't necessarily the easy way out. Another option is collaborative development and transfer, and I think within the Climate Ag Toolbox, maybe that's a place where you can see within CERC 2.0 that there is collaborative development. I don't know that the transfer piece is there, but certainly collaborative development. And this really connects with a lot of people issues and institutional issues. Collaborative development is where different teams are able to work on a single code base, and some groups, they may make big contributions to the code base, others may make small contributions to the code base, but it is that multiple teams or multiple groups are working on the same code base. When in a transfer situation, it may be that the academic institution or the team is working on the code base, but the operational agency does as well. That can work well, and I've seen it work well, but it can also pose challenges. And just as another quick example is that agencies may not be set up to do collaborative development. I think it's changing at some level. When I was involved with the National Weather Service and transferring some software to the Climate Prediction Center, they had never done collaborative development, even in-house. We had to set up a whole collaborative development process, which I'll talk about in a little bit, the elements of that kind of thing. But we had to set that up in-house and do training and get higher level approval for even doing that. and dealing with security issues. There were a lot of things that have to be done, including training of the other participants in that collaborative development team. Another option that's often seen as just an easy way out is to look at just releasing the code out as open source code. You can go to SourceForge or GitHub and other places to see where projects have just been released out into the open, thinking that other people will help keep a code base going. That can work, but it's not free. It really takes as much effort as the collaborative development and transfer approach. So in thinking about those other, the transferability options that involve other organizations, that is either turnkey or collaborative development or open source, there are a number of institutional issues that come up. That is things dealing with the policies. And if you're developing a tool that allows for customized interaction and customized computations, some of the policies that I've run into that have been really difficult to deal with are the ones that deal with allowing users to initiate a dynamic process. That is, to actually allow a user, somebody from outside an agency, to actually initiate computations. It's seen as a security risk. Other challenges deal with user registration and profile. Simply saving any information about users can be difficult for agencies. Other issues that are set at the institutional, kind of higher level institutional, higher within an institution, include what's allowed in terms of the software that's used to develop a tool. Within a university setting, we often focus on using the latest and greatest tools, but agencies may be 2 or 3 versions behind. That can make it challenging to even get people, IT people, involved in our projects who want to be working with the latest and greatest tools rather than working with tools 2 or 3 generations behind. There's other institutional issues that deal with what data and databases are allowable, what policies run access to those data and databases, what formats are allowed, and what are limits on access. These are all decisions that have to be worked out in any kind of either collaborative development or transfer process. And then there's things that seem so simple but can be so time-consuming, and that's an example of that is just the web page approval process. This is an example within NOAA that can be really problematic. At least as far as I know, up until maybe a year and a half or so ago, I don't think it's changed, but even a year and a half ago, web page approval, that is what a web page looks like, is something that has to go through a process that can take as long as 18 months. And then last is the notion of how do you handle security access after a transfer. If you're doing a turnkey transfer, will you have access to the code for your own research projects going forward? That can be a real challenge. And if you're doing a continuing collaboration, what sort of security protocols are even allowed to allow you to do that? So all of those are things that have to be worked out. And then in terms of thinking about collaborative development specifically, there are not just institutional issues, but there's sort of people issues as well. And these are the kind of things that the people involved in a project can have more control over, although not necessarily total control over. It may be set at higher level within the institution. But things like just planning the project and outlining the timelines and who will be responsible for the project, and then laying out the scope. Scope creep is a real challenge when it comes to some of these collaborative development or software transfer projects, as organizations need other kinds of IT support simply to build in building capacity to take on your project. A big challenge that I've run into is staff turnover. That's either within the research team or within within the agencies, particularly within the agencies. As staff turnover happens, having to just redevelop the capacity to participate in a collaborative process. There should be some decisions made in advance about how high-level design issues will be resolved. That includes just if it's a commitment to doing user interface testing, or simply what underlying hardware and software will be used to support the tools, or whether you're going to be a Windows system or some other kind of system. What kind of databases will you allow? Those are all high-level issues that at least need to be set within a project, but may be set higher level within an organization. And then how will the project be documented? Documentation, I think, often doesn't get enough time and effort. We're all in a production mode and having to get code changes done, but the documentation process is an important part of the process, especially if you consider staff turnover and that code will be maintained by junior programmers most likely over the long run. And this can ultimately end up breaking a transfer process, a tool transfer, even after it's happened, quote, successfully, simply because the documentation isn't there for a junior programmer to come in. There are task tracking issues that need to be managed in any kind of collaborative development. There has to be decisions about what kind of process will be used to and what kind of software will be used to track issues that come up with the collaborative development or the transfer, and then with specific tasks, whether it's a particular code task or a stakeholder engagement task. But there are certain processes and software tools for doing that. There are also software and tools and processes for managing the different versions of that back-end code for your decision support tool. And it's been really surprising to me to find that so few teams, whether it's in academia or in agencies, were making use of version control tools to keep track of changes that had happened. And so if there was an issue with a tool in operations, you could just go right back to a prior version while you figured out the problem and still have the tool be workable. And then there's also processes and software tools for doing code reviews. I've been surprised, again, in a number of collaborative development projects and transfer projects where individuals were responsible for particular pieces of code and no one ever reviewed their code. So it's within a collaborative project, code reviews do really help. It helps people both learn more about the code so that if somebody leaves, you aren't just left hanging, but it also helps develop capacity for further development of the tools. So that pretty much takes care of the transferability, and we're down to the last one here, so hang with me. And that has to do with the interoperability of the decision support tools or resources. If you were to think about decision support resources as being a checklist or a guidebook, this is a lot easier to think about, but we've got some special software issues that we have to think about too. So at the more general level, we've got these intellectual interoperability issues about who can use the tools and their outputs, how can they use them, are there limits on how they can use them, and how do we sustain that over time. So if you think about a guidebook or something like that, it's easy to manage. I've already talked about this within the CERC team at the last team meeting. We spent a period of time talking about copyright and copyright restrictions and the use of Creative Commons licenses as one way to provide certainty to users about how they can make use of the outputs and images coming from any kind of decision support tool. I'm not going to go over it here unless folks were to want this. I can pick it up in another webinar, but the shorthand version is that there are ways to provide licenses for use of the tool and its outputs in ways that provide certainty to users, that also provide restrictions on what they can do. It doesn't cost anything to make use of these licenses, in particular the Creative Commons license. These are established standards now, developed over the last 15 years and tested over the last 15 years. I would challenge anybody who is with a university or another private sector organization to take a look at your web pages or tools to see whether there is any copyright notice on those tools, or if there's not, that means that there's an implied copyright that really can restrict what users or intermediaries like consultants or extension agents can do with the outputs of your tools. So it's not so much of an issue with federal tools, but it certainly is with university tools. Other issues that deal with interoperability are definitely, this is the most technical of all the slides I've got, and I'm just about wrapped up here, but this is the most technical, and that has to do with how different tools talk with each other and how even parts of your own tools talk with each other. Some of the technical issues have to do with if you're trying to automate data, bringing data into a tool and then doing computations in the background, or you having sort of reviews to check the data, to check those outputs. Operational tools do this a lot, whether it's through an automatic process or asking people to look at the outputs in a kind of a random way or a consistent checking way to make sure that there hasn't been something go wrong with the outputs. And it can even encompass things like needing to do recompiles of the code as changes happen in software updates or browser updates and so on. Other issues deal with security and access, that universities and agencies differ in how much access they allow outsiders to have to their software or to their data, just in an access way, so that it may be worthwhile to set up a collaborative development or transfer project on a completely independent server through a third-party provider, because the university security requirements are too strict and the agency requirements are too strict. So having an independent third-party system to work on can be really helpful. And then there's questions about kind of how independent the whole system is, that is the decision support tool is, from the hardware and software that underlies it. Does a tool have to work on any computer platform, any operating system, with a number of different kinds of databases or different kinds of browsers? Or is it just much more limited to a particular configuration? And then the last in this section is whether, what happens to that code? Are you actually creating web services? Are you creating libraries as part of your code development? Or is everything integrated tightly into that particular software project? If the choice is that you're creating web services or libraries, then this next box applies, and that is, how can other people discover those web services? Do you even care if those web services are discoverable? I'm going to make a pitch that they should be discoverable, and it should be considered as part of your contribution, that is as an accomplishment in the beyond the development of the tool itself, but development of capacity, of kind of the IT capacity to support tool development. So that's, I know that's a lot of just kind of jargon and a lot of lists. The idea is that this framework, I'll be connecting through our team consults with each of the teams. I really am interested in finding out what are the goals and challenges you have in thinking about the sustainability of your tools. It's not for me to say what you should or shouldn't be doing. It's at this point, it's about kind of perfecting or improving this framework, connecting it to the goals and challenges you have, and then to think, I'd like to have more of a conversation with each of you about the processes that you are addressing and how you're doing that, whether it's the continuity of the code, the transferability of the code, and how that, and then the interoperability of the code with other systems. And then if there are any other kind of topics or issues that I've left out of this framework. So with that, I'll turn it over. I guess we can talk about this later at the other CERC meeting about sort of what the next frameworks, what the next webinars will be. But I think at this point, Megan, we can just open it up for questions.
Sure, okay, thanks, Holly. I guess if any of our CERC members have questions or comments, feel free to go ahead, and anyone else raise your hand and we'll unmute you.
So the CERC team folks are unmuted at this point, just so you guys know. If there's anybody else that had a question, please feel free to raise your hand and we can unmute you.
Well, folks are thinking about a question. I would just say that some of the challenges that I've laid out, people think that, or teams often think they can just hire out to a consultant to take care of, for example, long-term maintenance of their code, and so that their research team doesn't have to stay focused on it. They simply need to contract out and then bring in that money, those funds, to take care of the contract. There have been some successes that way, and there've been there's some real hazards in that way. An example I won't name, but within our own climate applications community, one group took that route, and it ended up that through the contract they developed, they kind of lost the ownership of their tool and had to rebrand and kind of rebuild. And that's happened in several cases outside of outside our sort of the RISA community, but within the broader climate applications community too. So just contracting out with consultants is not necessarily the easy way out. So if there are no questions, I guess I'll ask you a question if I can get some some discussion. Does this make any sense to those of you who are working on decision support tools? Does this framework?
This is Eric. Yeah, this is Eric. Can I say something real quick? Mm-hmm. Yeah. So yes, I just came in. I'm sorry, I was just a little bit late for the webinar, but I don't know if you talked about kind of the cost sustainability. Like, you talked a little bit about the interoperability and sustainability aspects kind of operationally, but what about, we are kind of in a unique situation, kind of in a university setting where, we have these funding for a certain amount of time, and then the funding goes away, and we develop a tool. We want to sustain the tool. It seems like there needs to be some discussion about how do we make sure that the maintenance and kind of sustainability of the tool has been developed in such a way as to make that very minimal. So then when the money goes away, there doesn't have to be a whole lot of effort, or at least minimal effort, to keep that running. So I don't know if there was any talk about that.
Yeah, I think in the introduction I talked about it as a topic and one of the challenges, and that notion of, I think that what you say is, how can we minimize that? And the reality is that over the lifetime of a tool, maintenance costs are the majority of the costs because you do get changes in the underlying, say, server hardware, or the software changes, security issues come out. It's not cost-free to have a tool run long-term.
I totally agree, and I almost think that, like, in the context of developing these tools, because we know that, you almost have to think about it in the sense of, when I'm developing this, how do I develop it in a way knowing that I have to minimize those aspects?
Yeah, so I showed that figure of the sort of the business view of this valley of death in working with tools or innovation or software, and how, you know, in business they expect that finally there will be some return that maintains the code from whether it's universities or agencies. That curve never goes up, and it's not clear what would sustain a tool other than having a dedicated source, a dedicated flow of funds. And so that's kind of your equivalent of success, is when it's moved into a dedicated line, right, for funding long term. And that's what happens when an agency like NOAA or the Weather Service says that a tool now is operational. It means they're making that commitment to sustaining that software and the data and the output and office support for interpreting that output for the long run. And that's why that the requirements for moving something from experimental to operational can seem so onerous, because it is equivalent. It's providing a dedicated flow of funds to keep that going.
Yeah.
If a tool stays in-house at a university, it's not clear, right? The dedicated flow of funds only comes through the dedication of proposal funding.
Well, I'll ask another question real quickly. You talked about discoverability, and you were talking about kind of data exposure from tools. I'm just kind of thinking about, you know, when I think of discoverability, I think of metadata. You know, when I think of tools that are generating data, that there would need to be metadata needs to be a discussion in there. So I don't know how much
that comes in. Yeah, I think that comes in with this interoperability, whether it's whether you have the coding, the web services libraries, hard coding. You could add just the metadata would be in there, probably in a separate list, in addition to that list.
Yeah, like as an example, like the data that I have working as part of some of the tools that I'm developing, you know, I'm thinking about, well, if it's exposing data as from the tool, and then another, you know, you might have an individual that wants to look at that data, but what you very may well have is another tool or another group wanting to use the output of that tool or some data that is related to that tool in their processes. And in order to do that, they have to have metadata that is associated with that information to be able to dynamically access it. So it's kind of all wrapped up in there in terms of, I think, how these tools are developed. If you want them to be very modular and useful, you have to be ways of the information that's coming out of the tool to be easily consumed in a dynamic fashion from some other systems.
Yeah, and I think conceptually that's the same as when you're trying to get the outputs of a decision support tool to be used in a decision process. And from your perspective, it's more of in a data flow process or a workflow process that may be with different kind of software tools, but they're very analogous. And it takes real effort to develop those things, and it's all in the background and not often seen as part of the research project. So. Any other questions or comments? I hope this wasn't too just like overwhelming or seeming like it's too much. It would seem maybe more approachable if it was just a set of checklists or discussion items. I'll be connecting with each of the teams through our consults to try to be able to kind of fill those questions or topic areas out, so that we can, it's more of a documentation about where CERC 2.0 is. It's not laying out sort of what you have to do.
I don't see any questions or hand raising. Give some folks a minute or two. Well, Holly, it's really been great to have you present the three presentations in this series, and we very much appreciate that. And if there's folks who've missed the first two.
Yeah, and here's a proposal for laying out the continuation of this. The next one would be focused on the utility of decision support tools, evaluation of the utility, and that's looking at how outputs actually move decision makers through the different stages of their decision-making process, and that's connecting with some decision framework through the National Academy of Sciences decision framework review. And then the next one after that would look at the suitability of tools, which is helping decision makers figure out which tools are right for them and how to position your tool so they see your tool as the right tool, if it really is the right tool. And then the next one would be on the user interface testing, which I know there's a lot of interest in, and there's some CERT 2.0 activity going on there already. So that's my proposal for the next set of 3 webinars.
That would be great, Holly. This is Dominique. I had one question. You must have heard about FedRAMP, right? If you serve data, government data, federal data, you have to get permission, and you need to be sort of blessed by the government, and you have to use a particular platform, a particular website. We are going through the whole process, and it's long and painful. So I don't know what your particular experience with that is.
Yeah, that's interesting. I wonder when that started, because as of 2014 or 2015, I had not experienced that at all.
Yeah, it just started.
And that's a huge burden.
It is a huge burden. We had to send out IT guy for a week in Washington, D.C. to get, and there are different levels of permission to use, the data. It's like if you're just serving climate data versus if you're serving data that DOD is using, different security levels, and it is quite a process. And so I was wondering if anybody in the CERC was dealing with that right now, because we are in the middle of it. And Mike Goff, who had created all these climate console, is learning that we have to change all the websites to make them, kosher for the government.
Mm-hmm. I'm sure there's some security issues behind that.
Yes.
And so is that true for data that can be accessed right now by anyone?
Yep. As long as it's data. Yeah. A website that has been funded with government funds has to be approved.
Yeah, the security issues for at least projects I've been involved with, when it comes down to the transfer, can end up being some of the most problematic issues.
Yep. Yeah. Yeah. If you ever want a small, a short presentation, I could get our IT guy to give us a little, a brief summary of what he had to go through. And
yeah, that would be really helpful, because those things are evolving. And it's even as of early 2015, I don't think we, at least with the NOAA data, we hadn't run into that at all.
No, it just started. I mean, it's like a couple of months old. Yeah.
All right. If anybody has any other questions that come up, please don't hesitate to contact me. And I look forward to talking with each of the CERC teams about this and kind of get a sense of where each of the teams are and how we can make this framework reflect what you're doing and then useful for going forward.